Hi, and welcome to this video on sketches, quadratic patterns, and sum formulae, brought to you by the Answer series. We're going to be counting the dots to see where the pattern comes from. So if we look at pattern 1, we have 1 dot. If we look at pattern 2, we have 1 dot and we add 3. When we get to pattern 3, it starts becoming slightly more hectic. So count the rows and then simply record in the table the number of rows that you have. Then go back and count your columns, and again, we're going to find that we have 1, 2, 3 columns. We go back to the table, record that information, take the product, which is 9. Now we are going to add into what we've already done the additional dots that have been added. So we had 1 and 3 from before. Now we're bringing in 5. Pause the video and try pattern 4 on your own. Okay, so 4 rows, 4 columns, the product is 16, and we added 7 additional dots. Pause the video here, think carefully about what you're doing, and then we'll go through it together. Okay, so pattern 5 is still relatively straightforward. 5 by 5 gives 25. And just following the pattern, we can get the 9 without really thinking. But it is important that we realize how we can create the 9 independently from the previous result. So when we get to pattern 10, we're going to multiply 10 by 10. But now we have to account for where this last number comes from. And very simply, it is 1 less than double the position. So if we want to generate the pattern for n terms, we've got n by n, which is trivial, n squared. The last number in that pattern is going to be twice n minus 1. Pause the video, see if you can answer these questions, and then we'll go through them together. Okay, so we discussed the pattern formula earlier. What we're working with here is a rule that helps us to calculate the sum of the first n odd numbers, which is pretty amazing. If we want the sum of the first 50 odd numbers, rather than add them very tediously together, we can literally just multiply 50 by itself, get 2,500, and that is the sum of the first 50 odd numbers. Quite remarkable. Moving on to rectangular numbers, we are going to use the same system of counting. So if we look at pattern 3, we have 3 rows. We go to our table and we put the 3 in. We go now and count our columns as we did before. But now you'll notice that we have 1 extra column. So our pattern is changing slightly. So we're going to multiply 3 by 4. That will give us 12. And when we're adding on dots, we have to process what has happened in that additional space. We start with the 2 and the 4 that we had earlier, and now we add the additional 6 dots for the new pattern. Pause the video and try pattern 4 on your own. Okay, so it's becoming quite clear that we simply take the pattern number plus 1, and the product, and that we then add on the next even number. To get that even number very easily, it is literally just double the pattern position. Pause the video, complete the table, and then we'll look at the results together. Okay, so we'll start this together from pattern 10. You multiply 10 by 1 more, which is 11. You get 110. The last value of the even numbers that you're adding is twice the position, so that's going to be 20. Your formula is going to be n multiplied by n plus 1, because you need 1 more. The short way of writing that would be n times n plus 1, and the last number in the expanded version is double the pattern number. Pause the video, answer these questions, and then we'll look at them together. Okay, so we've discussed the formula. It can be simplified out, and at times one might be better than the other. What we have done is work out a formula for the sum of the first n even numbers. So if I want to know the sum of the first 50 even numbers, I just have to multiply 50 by 51, which gives 2,550. It's actually easier to do that in an expanded form, to multiply 50 by itself and add 50. It doesn't really make any difference if you have a calculator handy. Okay, now if you look at this pattern, it's the exact same pattern we've just worked with. It's still a rectangular number shape, but we are going to be working independently with the red dots, focusing on them to create something called triangular numbers. So if we're counting now, we're going to be counting 1, then we're going to add 2 in, and then we are going to add 3 in, and then we are going to add 4 in. So think about that while we work through the next few questions. Pause the video, try this on your own, and then we'll go through it together. Okay, so if you're struggling a little bit with the rectangular counting, remember that this is 1 times 2, 2 times 3, 3 times 4, and 4 times 5. Also be observant and notice that the red dots are exactly half the total number. So every time you have an answer in the left column, you simply halve that for the right column. And what we're adding is literally, for pattern 4, the first 4 numbers, 1 plus 2 plus 3 plus 4. Okay, pause this video and see if you can fill the rest in on your own. Okay, so we know pattern 5 is 5 times 6, which gives us 30. We simply halve that, and we add the first 5 natural numbers. Pattern 10 is 10 times 11. We halve that, and we add the first 10 natural numbers. The formula for the rectangular numbers is n times n plus 1. We halve that, giving us a half of n times n plus 1, and we add the first n natural numbers. Pause the video and fill in these values, and then we will look at them together. Okay, so our rectangular number pattern should be becoming more familiar. Half of that gives us the triangular number pattern, which is rather convenient and helpful. What we have now is a formula for the sum of the first n natural numbers. So if we want to add all the numbers from 1 to 100 without any gaps in between, we simply take a half of 100 squared, a half of 100, and we get an answer of 5,050. Pause the video and try these on your own. Okay, so how did you do? In question 3.6, to start with, we are going to recall that the formula for odd numbers is n squared. The formula for even numbers, in other words, our rectangular numbers, is n squared plus n. Illustrating this with the number 50, we get 50 squared, and then we get 50 squared plus 50, and the combined result on that is 5,050. So this looks like something we've just done, because when we worked earlier with 100 natural numbers, we got the same answer. This is difficult to understand, but we have a total number of natural numbers that is twice the number of the individual odd numbers and even numbers. So when we're comparing formulae, we have to put a 2n in here because there are twice as many numbers in the triangular formula as there are in the 2 separate odd and even number formulae. All right, so simplifying that answer out gives us 100 when n is taken as 50, as we substitute here, and we get the same result of 5,050. All right, and to just look at that complicated explanation one more time, n squared represents n odd numbers. N squared plus n represents the sum of n even numbers, giving us the result of 2n squared plus n. When we're adding the same numbers combined into one sequence, we have twice as many numbers because we are counting now for the odd and even, so we have twice as many numbers as what we had individually with our odd and even sequences. When we simplify that out, we get 4n squared and n, and multiplying that out gives us 2n squared plus n. So we have confirmed that the 2 sets of formulae can be combined to produce one result. This was complicated. I hope you found it interesting, and I hope you enjoyed it.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.